All right, we are continuing with our lesson, and we are looking at forces. Okay. After looking at contact and non-contact forces, we are going to continue, look at another section of forces.
Bruvs.
Oh,
How are you?
Okay, I want us to focus now on this, looking at force and gravity, force of gravity and weight. We saw that gravitation force is a non-contact force. And now we are going to see how this one gives us how it connects with weight. Weight is a force, and each of us has weight. Because if you have mass, then you have weight at any point. So we are going to look at how force of gravity affects weight and how the two connect to each other. Now we are going to, let us look at the definition for gravitation force. We have discussed that gravitation force is a non-contact force. And now we are defining it as a force which pulls objects towards the Earth's surface or towards the ground. A force which pulls objects towards the ground, which you can say towards the Earth's surface, is what we call gravitation force. Force which pulls objects towards the Earth's surface. Briefly, that is what we need to know. So it can also be called the force of gravity, or it can be called the gravitation force. In our last discussion, we said it's a non-contact force because it doesn't need to be in contact with another body for it to act. So for it, it's a non-contact force. Someone is asking me about balanced and unbalanced. That one will come later. We'll look at it later. I think Shan, your hand is up. Yes, Shan.
Definition of gravity force. F.
Yes.
Pardon.
Please let us mute our microphones. Someone is telling me that if they ask you for the type of forces, you say contact and contact. Now, those are the how we classify them. Can be either contact or non-contact according to how they work. So that is a classification on how these forces work. But if they ask for the types, there are many. The types are the gravitation, the friction. Some people give them as examples, but they are also what we would take as types. Another person would take types as contact, non-contact, and then gives these ones as examples of those, which is also fine. So long as you know how to apply them in a given question, because they can ask you maybe give 5 examples of forces, so you can't say non-contact and contact. So you have to give many of the forces that we have looked at. I want to know the meaning of reaction forces. Yes, we are going to see everything. You just have to follow these lessons step by step. We'll reach there. You're going to see what reaction is, what balanced and non-balanced force is, and what is a resultant force. All those ones, we'll look at them. But let us focus on what we have for now. Okay, we have seen the definition. And now I want us to look at weight. Now we are going to define the term weight. We are going to define the term weight. We are going to define the term weight. Now, weight, I'm going to write the definition here, and you have it. Now, when you get maybe a heap of books or a bag or a jerry can and you put it on your head, you feel something. You feel something heavy on you. You feel something heavy on you. So it means that this body that you are putting on your head is exerting something on you. So the force that the body that you are carrying maybe on your head exerts on your head is what we call the weight. If you sit on a chair or on a table or something where you sit, your body exerts a force onto that surface on which you are sitting on. So that one is weight. When you get a flask and you put it on a table, that flask is exerting a force on that table, which we call weight. So that feeling that you get when you get a jerry can or a bag and you place it on your head, then that one is what we call weight. So indeed, we can define weight as a force applied by a body onto or on a surface which it rests. So the force that a body applies on a surface on which it rests, we can call that weight. And sorry. So I'm redefining weight here. Weight, we have said it is a force applied or force exerted by a body onto the surface in which it rests. So that is what we call weight. And weight is a force. Weight is a force. First of all, you have to appreciate that weight is a force, and therefore it will be measured in newtons. So a person can ask you, how can I determine weight of a body? Now, weight of a body, we call it W, is got or is determined from mass of the body multiplied by G. Now, I'm going to tell you what this W means, what this M means, and what this G means. W is the weight of a body. So W is the weight of a body. If I need to get that weight, I must know the M, which is the mass of the body. Must know the mass of the body. And this mass is in kilograms. This mass must be in kilograms. Remember, our weight is in newtons. And this G that you are seeing here is what we call, in physics, we call it acceleration due to gravity. acceleration due to gravity. Now, the term acceleration briefly means change in speed. Now, how speed changes due to gravity is what we call acceleration due to gravity. And on Earth, you note me, on Earth, the value of acceleration due to gravity is constant or is the same, and it is 10 meters per second squared. It is 10 meters per second squared. It is our acceleration due to gravity. So our G around here is 10. So if someone gives me a body, maybe a body has a mass of 2 kilograms, and a person asks me, what is the weight of that body? What I will tell this person is that the weight of the body will be equal to the mass, which is in kilograms, and the mass is 2, times acceleration due to gravity, which is known as 10 meters per second squared. Therefore, our weight will be equal to 20 newtons. So that will be our weight. So if someone asks you about weight, just tell that person that the weight is the product of mass and acceleration due to gravity. That is how we calculate it. But it is defined as force exerted by a body onto the surface on which it rests. That is how we define weight. So that is it so far. Any question about what I've just told you about, you can raise up your hand and ask, or you write in the chat. I do the questions, then we see something else. Wasn't 2 kilograms supposed to be 2000 G? Please, G is acceleration due to gravity. I've said that what we have, we get a 2 is mass in kilograms. The mass that we use to calculate weight must be in kilograms. And I'm telling you that G is acceleration due to gravity. When we are calculating weight, this G does not mean grams. It is acceleration due to gravity. So you get the kilograms as it is, and then you multiply by acceleration due to gravity, which is a constant. A constant means it is given to you always on your papers. Maybe that one is 10. Someone is telling me, is it a mass that we have to multiply by 10? Yes, because acceleration due to gravity is 10. You read some books, maybe on the internet, they will give you a value as 9.8 or 9.9, but that value on Earth at our level, which is S1, we use our value as 10 meters per second squared. That is a constant. It's like if you have maybe, which one can I use? Area of a triangle where you say a half times base times height. Now that a half is constant. That a half is there always. So even here, the 10 is a constant. So long as you are on Earth, that 10 will not change. It will be 10. It only changes when maybe you go to the moon, to other planets. That's when the value changes. But in our calculations for weight on Earth, we usually use 10 as acceleration due to gravity. I've told you the term acceleration only briefly means the change in speed. Maybe you are moving on at 20 kilometers per hour, but then you increase your speed and it becomes 40. Now the rate at which that speed is changing, is what we call acceleration. So I was telling you that the rate of change of speed that is caused due to gravity or due to gravitational force is what we call acceleration due to gravity. The rate of change of speed of a body caused by gravitational force. And I've told you that that one is 10. Okay? Okay, some questions maybe we'll answer as we continue. Someone asks us about mass on Mars and then wants us to find the weight. Now, you cannot find the weight of a body if you don't know the acceleration due to gravity. At that point, if they ask you for weight on Mars, then they must have given you the acceleration due to gravity of Mars. If someone doesn't give you acceleration due to gravity at that planet, it will be impossible for you to determine the weight if you were to use this formula. So this formula requires someone to give you the acceleration due to gravity. So I've told you that a mass must be in kilograms, and then the other thing does not change, the constant. Now the constant will only change if we have acceleration due to gravity on different planets. Let me try to look for some of them here. So according to what I have here, sorry. according what I have it that the acceleration due to gravity of the following maybe of Venus is 0.9 times the 10. That means for it is 9. For Mercury is also a planet. It is 0.37 times the 10. That means for Mercury, the acceleration due to gravity is 3.7. Someone was asking for the moon. Okay. What I was trying to tell you is that the acceleration due to gravity will differ according to which planet we are on. That's why, as the mass of a body remains the same, the weight of the body will always change. What do I need here? Someone was asking, why did people put on heavy clothes at the moon? First of all, at the moon, the gravity is low. So if a person is at the moon, if he doesn't put on heavy clothes, then that person will find it difficult to move at the surface of the moon. So you'll find that person floating instead of moving at the surface. And it will make that person uncomfortable there. So that is one reason why they put on heavy clothes up there. So I want us to do something small before we finish. At 3:30, we are going to have a table here. This table is going to help us do one thing. We are going to give differences between mass and weight. We are going to list down differences between mass and weight. So you are going to help me between mass and weight. So this side we are going to have mass, whereas this side we are going to have weight. So we are going to give differences according to that. Now, someone was asking us, to explain why weight changes from place to place. Now, the only thing that changes weight of a body is the acceleration due to gravity. So because acceleration due to gravity changes, maybe from the Earth, the Moon, maybe at the center of the Earth and at the poles, there is a slight difference between the acceleration due to gravity at those 2 points. The poles of the Earth may be North and South Pole, and in the middle of the Earth, where we have the equator, we'll find out that the acceleration due to gravity are slightly different. So you will find that the weight at those points are different because of that. So the only thing that brings about difference in acceleration due to gravity, in weight, is acceleration due to gravity. That's why weight for it changes from place to place, because the acceleration due to gravity also changes from place to place. So someone is giving us differences now. One person, Austin, is saying mass is in kilograms, whereas the other one is in weight. Yes, my friend, what do you have to say? Your hand is up. So this one
Mass is constant
while weight
changes from place to place.
Okay, thank you. So mass is in kilograms, whereas weight is in newtons. That is one answer I got from the chat. The other person said that mass is scalar. Scalar means it has only size. We can never say that this person is 4 kilograms east, because mass is only a scalar quantity. It has size only. Whereas for weight, because it has acceleration due to gravity, for it becomes a vector quantity, because weight has direction on it. So weight is a vector quantity because it has both size and direction. Primus also says that this one is a fundamental quantity, whereas this one is a derived quantity. Yes, that is also correct. This one is derived, whereas the other one is fundamental. Fundamental quantities are those ones which can't be expressed like others. So we call them fundamental. Yes, any other difference? Austin is saying that mass is the quantity of matter, the body, whereas, so you can tell us that in definitions. Another difference can come if someone told us this one is constant. This one is constant. Constant means it's the same. Even if you go to the moon, this one remains the same. It is constant. Whereas this one changes from place to place. The other one is the definitions. The other one is the difference that can come in. As what the instrument used to measure is also a difference. Mm. Okay. So that is it for now. And I remember someone also asked me something about reaction when we are just starting our lesson. Let me also answer that before I leave. If someone tells you reaction, it is that we have a body resting on a surface. Now, when it is resting on a surface, it is applying what we call weight. It is applying its weight on that body. Now, because this surface has also a reaction, it has a force is also applies to the body. So that force will come out as a reaction force. Like the word itself, the surface is reacting to a force that is applied towards it. Now, this is what helps this body here to settle, this one here, to settle on the surface without moving, because there is a downward force, which is weight, and it's equal to the upward force, which is a reaction. And these two are equal, but they are opposite. Opposite means that one is in one direction, then the other is in the other direction. So this one here is what we call a reaction force. It's telling me, ask me a question. I'm forgetting which question. Humble, you help me type the question again. I will answer, please, before I leave. If you are there, type it first before I leave, because we have to go for our computer lesson soon. I remember answering that question, why astronauts put on heavy clothes. I said because there is a small value of acceleration due to gravity, and therefore, because they want to remain on the surface of the moon without floating, they have to put in heavy clothes, which increases their mass such that they can move properly without floating. So because the acceleration due to gravity is small, so you need to have a heavy something so that you can walk properly. For example, if you see a polythene bag, if it's thrown upwards, you'll find out that you will find out that it can go even up there when it is windy, but you can't go up there when it is windy, because for you, you have a heavy weight. Yes, someone was asking me, how can I get the mass of a person on Mars? Mass is constant all over. It will be the same value. That's why we said it's constant. Humble, mass is the same. If you are 60 kilograms on Earth, you'll be 60 kilograms on Mars, you'll be 60 kilograms on the moon, you'll be 60 kilograms everywhere. What changes will be the weight. And we said that to get weight, you just have to get that mass that you have and you multiply it with the acceleration due to gravity of that planet. And it will be given to you. A question like that is asked. Someone is asking me to pardon her reaction. Reaction, I've said that if to keep a body stable, on a surface on which it rests, a body also, if you exert your weight on that body also reacts with the same value of weight, such that if you are seated on a bench, that bench won't fall in, because if you are putting your weight, then that means that for it to be stable, there must be an upward force which is equal to the weight that you have applied on that surface. That's why even the surface itself will give you another force, which is the reaction force. So reaction is an opposite to the weight. Reaction is the opposite force to weight. That when weight is applied on a surface, the surface also applies that force, which is called the reaction force. Okay, you will allow me for today to stop there. We will continue with our forces. We will look at other things that will come up in our next lessons. We need to go for computer. The ICT course lesson is going to be here. So please, I'm going to leave, but you shouldn't leave, because the teacher is just going to enter in and continue from here. So the ICT lessons are also here. You just keep in. Don't leave. Otherwise, I wish you a nice lesson and a nice evening. I think I should say bye-bye to you. You have a nice evening.
S.1, what are you doing? S.1, what are you doing?
How are you guys?
We're not fine.
Why?
Wait.
Amen, 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 amen.